My name is Maciej Pilecki, and I'm actually the main organizer of this conference, as it happens. So I took the opportunity, and actually this session was voted for during the call for papers and then the session voting, so it was popular enough to put it on the agenda, despite the fact that I'm not going to be talking about anything that you can I'm not going to be talking about anything that is a SQL Server functionality per se. I'm not going to be talking about Microsoft product, and I'm not going to be talking about the product that you can buy right now. So I'm talking about my own product, and it's a future endeavor. So it's kind of work in progress, what I'm showing you today. So I would like to introduce basically SQLProxy. But before I do, let me start by telling you a little bit about myself, for those of you who don't know me. I'm a Microsoft certified master in SQL Server, and have been doing a lot of work around scalability. So I've been a SQL Server consultant for a while. When I don't organize SQL Server conferences, I do a lot of SQL consulting, mostly around performance tuning and scalability, those types of problems. So I've seen a lot of different things, and I've been working on large-scale SQL Server deployments. Some of them kind of ultra large scale, some of the biggest in Europe, for instance, where large scale doesn't really mean big data. What I typically work with is not a database that is huge. I mean, of course, multi-terabyte databases are often there, but sometimes I work with databases that are relatively small, a couple hundred gigs, something like that. But they have one interesting thing. The workload is extremely intensive, right? So we're talking about workloads where you do thousands upon thousands batches per second, or you do, I have one installation where we do about 8,000 batches per second on 16 different instances of SQL Server, and that's actually like one solution. So many of those, very high throughput, very demanding, very mission critical type of stuff. And I've seen my share of scalability problems of all kinds, locks, latches, spin locks, tempdb, etc., you name it, and I probably worked with that. And I've learned that it's extremely difficult sometimes to overcome some of those problems, especially if you don't own the source code for the application, or you cannot modify the application and how the application interacts with your database server. If you're just a DBA and your server is getting hammered because someone did a really bad job designing or developing the application, your hands are pretty much tied. There isn't that much that you can do. Right? You try to keep up with the incoming traffic and an incoming workload, but it's not going to always work. So the problem with database scalability, and I'm talking specifically about SQL Server because there are solutions for other database platforms. Other database platforms very often have different characteristics, but the problem with the SQL Server database scalability is that everything changes at large scale. Right? Something that works perfectly well at 500 users will tank at 1,000 or 1,500 users. Right? You double the workload or you triple the workload, and all of a sudden something that worked just fine not only doesn't keep up with the throughput, it actually breaks and stops altogether. So as the workload increases and it's more and more complex and there is more and more interaction between different queries being run, you get a lot of contention. Right? We build those huge databases, huge SQL Server instances. Right? We keep everything in a single database, in a single instance. Right? We give SQL Server 64 processors. We give it a terabyte of memory, etc., etc. And then we try to keep up with this huge workloads. And what happens is that since it's in a single process, it's a single SQL Server instance. And then there is a lot of contention. This contention can be on many different things. Most typically, it's going to be, of course, logs, transactional logs, readers blocking writers, etc. Latches. on your data pages if you have any hot pages that are updated frequently. Spin locks, depending on what you do inside your SQL Server engine. Memory for query execution. TempDB is kind of a bottleneck by design because everything goes there. And if you start doing something that is TempDB intensive, you only have one TempDB per instance. So everything lands in that single database. And if you left it at the default configuration with one data file, then it's going to be really nasty because there's going to be a lot of contention on that. Even the query optimizer itself can be contended for because it's throttled. You cannot make more than a particular number of optimizations per second in query optimizer to make sure that the query optimizer doesn't use too many resources. So if you do too many query compilations, right, you have 10,000 batches coming in, and I don't know, let's say at 10%, so 1,000 of them requires a plan to be optimized and compiled. Your query optimizer itself is going to be overloaded with work and will be a place of contention. What it might look like is like this. The red line is the throughput, right, in terms of number of transactions. And as the number of requests grows, right, from 0 to 90,000, we can see that, so the blue line is contention. In this case, it's a contention represented by spin locks. So that's a particular type of contention that shows here. But in any situation where you have a resource contention, you will see more or less the same pattern. Right? As the workload grows, you will see throughput growing as well, then it will level off, and then it will start dropping as the contention becomes a problem. Right? And the more contention you have, the more drop there will be. And it might be a cliff, just like, you know, at some point it just breaks and stops working completely. So that's what you might see in terms of database scalability, right? If you push it too far, it's going to break. So of course, part of your job as a DBA is to find that sweet spot, right? To try to be on that plateau over there on the top, if possible. But a lot depends on your workload and how the application was designed. There are two approaches to scalability in databases, in SQL Server especially, right? One is scale up, which is exactly what we do today. You know, just buy a bigger server. Everyone thinks that buying a bigger server, throwing more hardware at a problem, is a solution. Sometimes it is, sometimes it's not. Depends. The biggest problem is that it is expensive, because the bigger server you buy, the more expensive the hardware is going to be, and the more expensive the licensing for your SQL Server will be, right? You're going to buy, you will have to go from Standard Edition to Enterprise Edition because you bought a bigger box and you exceeded the limits for Standard Edition, right? And the price for the hardware grows almost exponentially as the capacity of that hardware grows, right? So it's not like buying twice as big server is twice as much expensive. It's going to be like 4 times or 6 times as expensive to buy a box of twice the size. And the problem with scale up is that we still keep everything in one basket, right? It's still a single instance, it's still a single server. So if our problems are contention related, it's not going to get better at all, right? Because you just want to have more workloads and more worker threads running inside your SQL Server engine, because now you have more processors, and now all this, but the resource that was contended for is still there, and it's still the same resource, so you will see the same effects, and it's not going to get faster, or it's not going to get significantly faster. In some really pathological cases, it might even get slower as you put your workload on a bigger server. I've seen that. So another solution is scale up. Sorry, not scale up, it should be scale out. Sorry for the mistake. Scale out is where we buy more boxes. Okay, so let's try to spread the traffic, spread the workload across multiple SQL Server instances. Right? You know, just like many companies do, you know, buying commodity servers and then building a data center out of that. So instead of buying huge enterprise edition server, how about we, just buy 100 small servers and put a SQL Server Express on it and spread the database, and it's going to work, right? Sounds like a great idea, except it's very difficult to do. So scale out is typically some form of data distribution and then load balancing of your workload across multiple instances and multiple databases that might be holding either a full copy of some part of your data. So it might be replication, it might be federated databases or federated servers as they used to be called. It could be log shipping, so you have this readable secondary standby database that you could try to use, etc. You have always on readable secondaries now that you could take advantage of and send some of your queries to that secondary. All that sounds pretty cool, except in practice it's complicated to the point of impossibility, right? Try to do it in production and you're going to be banging your head against the wall. Because in order to do that, you need to change the way your application interacts with SQL Server, and that requires not only code changes, it often requires serious architectural changes in your application. Right? So for instance, always on readable secondaries, a cool feature, right? They're kept in sync, so everything is it still working? Yeah. Everything is in sync, so the readable secondary is in sync with the primary, and you could offload your read-only queries over there, but how you actually do that? Well, so the problem with always on is like this. Readable secondaries, as the name suggests, allow read-only queries. Sounds like a perfect solution for scale out and load balancing. Let's just, let's do inserts and updates here, and let's do all our selects across those 2 or 3 replicas, for instance. All right? Yeah, we could do that. I mean, technically it's possible. But there's nothing in the SQL native client that would allow that, right? We have read-only routing on listeners, but that only means that if you specify that your intent is read-only, the listener will tell you where to go. And it will redirect you to another server. But if your application doesn't go and say, I'm going to be executing just read-only queries, you just connected through the listener always to the primary replica. So that doesn't get you anywhere. So in order to do that in practice, what you would need is 2 database connections instead of 1 in your application. Right? 1 database connection for all your read-only queries to the readable secondary, and another database connection to the primary replica for read-write queries. Right? And you would need logic in the application so the application knows when to use which connection. Okay? There's nothing in the SQL native client that will do that automatically for you. So you actually need to understand, okay, now I'm doing an update, and now I'm doing a select, so I'm going to be using this database connection instead of that database connection. Just imagine the amount of code changes that it would require in any application. So a lot of those changes, and they are very often either very difficult or just impossible. Right? This is actually most likely not possible for any existing deployed application, unless you really go kind of back to the drawing board, redesign the application, spend a lot of time rewriting it, and then redeploying it. Right? Assuming you actually own the source code, because what if it's a third-party application? Right? They'll just tell you, well, no, we don't have plenty plans of supporting this or implementing anything like that, so we're just going to stick to 1 server. So that's the problem with always on. Another interesting thing about workloads. In most workloads, vast majority of your batches will be selects or read-only queries of some kind. It's like, if you have 10, 20% of actual updates, that's kind of the typical ratio that you see, right? Of course, it might be different for different workloads. Those selects are often small read-only queries that look absolutely innocent, right? I mean, select star from this and that, where something. It's like a simple query, normally runs in 5 milliseconds flat, doesn't take much resources. What wrong might possibly happen there with such a tiny and fast query? But you mix them with some number of updates, of transactions, and it could be enough that just one of those transactions is long running. And your innocent small selects become a weapon of mass destruction because they all block, right? And they start consuming more resources on the server than they should because, you know, as long as your query is blocked by a, let's say, a row lock, the worker thread is tied up. And if you have too many of those, because this guy is still updating and is running, and the other guys are starting to queue up to the point where you actually run out of worker threads, and your SQL server does not respond anymore. You cannot even connect because there are no worker threads to service your login. So this, you know, I've actually seen that in the wild. You know, just a small update, bang, everything blocked, the application is down, everything is down. Reads blocking writes, writes blocking reads, and vice versa, you know, and lots of contention because you have a mixed workload. You're doing a little bit of inserts, a little bit of updates, a little bit of deletes, you know, and selects on top of that just block. And of course you can try to lower your isolation level or go to read, you know, read committed snapshot, but that's going to put some more pressure on your TempDB, and probably if you're already in trouble, you're going to be even more trouble with that. Another interesting thing about workloads is that many workloads include a very high number of queries that return the same data over and over again, right? I've seen queries in real workloads with real applications where a particular query, verbatim, the same query every time, would be executed 100 million times per day, right? I mean, of course, that gives you the figure about, you know, some idea about the size of the workload as well. But, you know, if you just, someone had this idea, okay, let's, you know, we need this data often, so we're going to just reach the database, or we're going to be polling that table to see if something new is there, and then you multiply that by the number of applications out there, etc., and all of a sudden, it turns out that, you know, it's not 3 times per second, but it's, you know, 300,000 times per second, etc., So, queries that are executed over and over and over. And very often, they represent the most significant part of the workload. Not the big guys, not the big queries. The tiny little guys that are executed so often. So the application asks the same question over and over and over, and it gets the same answer because that data doesn't change, or it changes very infrequently, you know? 2 plus 2 is 4. And it has been 4 yesterday. And it's going to be 4 tomorrow as well, and it's not going to become 5 anytime soon, right? But the application will just keep asking, you know, select star from, you know, select count from, and so on and so on. Just intensively querying your server. Even if the data changes, it changes infrequently. But the work on the server has to be done each time. Because SQL Server does not cache the query results. It caches execution plans and data pages. So it actually runs your query every time you ask, right? It needs to, even if it's select star from this table, that result needs to be assembled and sent over the wire to your application, and that takes server resources. So it's resource usage and possible contention in many places, because that select star from, unless it's executed with no lock, or even if it's executed with no lock, can block because someone else is doing something against that table, right? So I have this insert running or an update running against that table, and then your select that should be done in no time flat all of a sudden blocks and waits for me to finish. And all kinds of problems start with that. So enough of the introduction, okay? So that was the problem that I've been facing for many years as a SQL Server consultant. You get this workload and you try to make the best out of it, but you kind of, you know, have a facepalm moment looking at how the application is written or designed, right? It's like I wish I could change the way this query is written, or I wish I could change the way this application interacts with my server, how it asks all those queries. So, yeah, a lot of potentially unnecessary queries because we're asking the same thing over and over and over. So I started looking for a simple solution, right? I'm a fan of simple solution. I believe in Occam's razor. You might want to look it up, right? Occam's razor says that, you know, typically the simplest solution or the simplest explanation is the best one, right? We shouldn't unnecessarily complicate things. So I started looking for a simple solution, and I started asking myself some questions. Like, what if you could cache queries? Like actual query results without having to run those queries every time. And how would you design a functionality like that? What if we could scale out to other servers without any need for code changes? You just take any existing application, plug it in, and it magically spreads across as many servers as you want. What if we could fix some of those monster queries on the fly? Like, without touching the application code, because, you know, I'm just a DBA. I'm not allowed to touch any C# code out there. You know, there's sacred C# code with all the bullshit queries inside. I'm not allowed to touch that, so I'm not allowed to change those queries that are generated by the application. Or they might be generated by some data access layer, such as, I don't know, Hibernate or Entity Framework or something like that, and they just don't perform. But you don't have direct control over them. So you just, like, you know, take it or leave it. This is it. This is the workload. That's what it's always been. So what if we could fix those queries without touching the source code for the application, without changing anything in the application, so that they still return the same result, but they do it much faster? And we all know that we know how to fix queries. We know how to optimize them, right? Small syntax changes often yield tremendous performance results, right? Wouldn't that be a dream team, you know, a dream tool of every SQL consultant out there, right? A tool that allows you to do magic with any application out there without the application even knowing, and without the application developer even knowing, of course. And then the idea of SQLProxy came to me. So I've spent the last 2 years when I wasn't busy consulting about SQL Server and tuning your workloads, and I wasn't busy organizing SQLDay, I was writing some code with my team. And we created what we call SQLProxy. And a SQLProxy implements some of the functionality I just told you about. So what it does is, it's a fully transparent TDS proxy. From an application perspective, it looks and behaves like SQL Server, right? It is SQL Server and T-SQL aware. We actually use full fidelity T-SQL parser inside. We know exactly what you're doing. And we understand the context of your connection. We understand what you do over that connection. We know if you open a transaction, etc., right? We're fully aware of what's going there, what's going on. We essentially control the communication between the application and the server, right in the middle. And now I'm in control of what queries go where and what queries get true, right? I don't like your query, I can kill it, right? Send you an empty result set or an error message or anything like that, right? And the functionalities of SQL Server, what we have so far, include routing read-only queries to readable secondaries in a manner that is completely transparent to the application. Caching the query results, and it's fully configurable. You decide what gets cached and for how long. And basically, if the same query comes in, we'll just serve you the same result, right back at you, without the query ever reaching the server. And dynamic query rewrites, which is a kind of a niche functionality, but I thought it was so cool to have, I decided to implement that. That's one that I'm not going to be doing a demo today. So let's start with routing of read-only queries. So as we discussed, you can offload some of your part of your workload to the readable secondary, if you know how to do it. If the application is aware that, okay, now I'm doing reads and now I'm doing writes. But the application is not aware, and since we don't have anything in the SQL native client that supports that, we provide that query routing. So basically, you connect to the proxy, and we look at your queries at the batches that come in, and we say, okay, so now you're doing an insert. Okay, we're going to send you over there, because that's the primary replica. Oh, now you're doing a select. A select is a read-only query, so we can send you over there. And basically, we route those queries between servers in the always on availability group. It's fully configurable and customizable. So the way it works, right? You have your application server at the bottom, SQL proxy between the application server and your always on availability group. So essentially 2 SQL Server instances running in a cluster. And you point the application at the SQL proxy. The application thinks, this is my server, this is my database server that I'm going to be talking to. And it's the same connection, right? You just change the connection string, or you can use DNS or the host file or anything to just redirect it, right? We're going to be sitting on 1433, and you're not going to be able to tell the difference between SQL proxy and your actual SQL server behind it, right? So the application connects to the proxy itself, and it talks to the proxy just like it was SQL server. And the SQL proxy decides which queries go where. So basically, in the background, we're going to open 2 connections. We're going to open a read-write connection to the primary replica and send all your read-write queries over there. And we're going to open another read intent only connection to the secondary replica and send your read-only queries over there. Right? And we can do it in a couple different ways. So how this read-only routing works? First, you configure your SQL proxy to connect to the availability group listener. It should be AG. Availability group listener. We connected the listener, and we asked listener about what's going on. We essentially use the routing information that the listener gives us to open a read-only connection to the readable secondary replica. So using the listener, you always connect to the primary, but you can get this routing information. It will tell you, oh, if you only want to just read, then there's this readable secondary you can go to. And we're going to use that, and we're going to open those connections appropriately. And then the application opens a single connection to the proxy, and every batch is classified and executed on the appropriate server. And that classification, how we decide whether something is read-only or read-write, can be done in 2 ways. That classification can either be declarative, so basically you can say that a query that matches a certain pattern or a certain hash, we use hashing to match those texts, you specify that this query is a read-only query that should be executed somewhere. Or it can be dynamic by essentially parsing. So we can take your batch, parse it, and then look at the parse tree and say, okay, all the statements that we see in this batch are read-only statements. These are all selects and declares and stuff like that. We don't see any updates or inserts in here. So you're good to go to the read-only server. Of course, that carries an overhead, right? I mean, parsing is obviously expensive. And actually, I'll tell you that the Microsoft provided full fidelity T-SQL parser is the slowest part of SQL proxy, right? Because it's just complicated. So it does work, but it comes with a cost, and it might not be what you want to do. So let me show you a small example of that. Let's hope my demo works. I'm using a bit of a unstable version. So what I have here, I'm connected with a management studio to SQL proxy, right? And as you can see, it thinks it's just a normal server, right? So my management studio sees databases, etc., because it's really talking to the SQL server behind the proxy. It's just like a web proxy. You talk to the web proxy, and that gets you the results from the web server. And we do the same here. So I have, if I do select server name, I get SQLAW02, which actually is the read-only replica for my availability group. I'm connected to AdventureWorks, which is part of the availability group, and since I'm doing a select, that select goes to the read-only replica, right? But, so if I do a select from a table, I get 2 rows, etc. If I do an insert, and then I do that select again, I see 3 rows, everything works as expected, except that insert and that select executed on 2 different servers, right? Without the management studio ever knowing. From the management studio perspective, just like for your application, this is a single server. We're talking to a single server. Everything that happens inside the proxy is fully transparent. So, but let's say, oh, you want to run something on the read-write, on the primary replica. How would you do that, right? So one of the solutions is that if you open a transaction, right? If you begin transaction, and if you're doing something inside a transaction, right? You do essentially a multi-batch transaction, then we know that you're likely going to be doing some updates or something like that, otherwise you wouldn't be opening a transaction. And then whatever you do, we send it to the primary replica. Right? So as long as this transaction is open, all my queries go to the primary replica. But the moment I close my transaction, my read-only queries go to the secondary replica again. Simple as that, right? And if this replica is a synchronous replica, there is a very little gap between inserting a row here and seeing that row on the secondary replica. There is a gap. It's not instantaneous. It's not exactly the same, even in fully synchronous availability group, because when it says synchronous availability group, what it really means is that the log records are hardened on the replica. But the redo thread now has to redo your transaction and actually physically insert those rows. So there's a tiny gap between I insert a row here and I see that row on the other side, right? So if your application can live with that, you're good. If not, we have some other solutions in mind to make it happen. So that would be routing, just a simple demo. You know, one connection from an application perspective, 2 servers behind, and queries being executed on different servers. The other functionality I wanted to tell you about is query results caching, which is I'll be honest with you. Initially, when we first designed SQLProxy, I wasn't thinking about implementing that. I thought, oh my God, that's just going to be nasty. It's going to be too difficult. There are just like, we didn't really see that use cases, etc. And then I started talking to some of my customers, and it turned out that this is something that they were really interested in. Yeah, we want the data. We want to, offload some of the workload by essentially not executing it, because we can cache those queries. And yeah, we're fine. We can live with data that is, maybe a couple seconds or maybe a couple minutes old, etc., etc. I said, okay, fine. And then I started designing it, and it turned out that this is right now my favorite functionality inside SQLProxy. So how it works? Query result caching is based on the fact that SQL Server caches many things, right? That's why it needs so much memory. It caches, data pages and execution plans for your queries and things like that. But your query is executed every time you send it, right? If you have the same query coming on 2 connections at exactly the same time, that query will be executed twice. Right? I mean, that execution plan will run twice for each connection separately. It's not like, okay, let's run it once and, take those results and send it to both guys because they're essentially asking for the same thing. No, it doesn't work that way. Every connection on its own, right? Every execution plan gets executed every time you ask for a result. So the solution, the simple solution to that, right, because we like simple solutions, I already said that, caching the query results. Not the data pages and execution plans that tell you how to execute your query. Because that's not going to get you anywhere, you know. Many of your simple, you know, innocent selects end up spilling to TempDB, for instance. You know, you might have a short spiel or hash spiel, or you do something that requires a work table in TempDB, and your select is no longer a read-only. It's not truly read-only, because all of a sudden it does a read-write transaction in TempDB. And that slows you down, and that creates resource contention and resource consumption on the server. So that's not what we want. We want to cache the query results and essentially recognize the fact that, oh, it's the same query. You know, you or maybe someone else just asked the same question 5 minutes ago. And you know what? The answer hasn't changed. Bang. Right back at you, you know? 2 plus 2 is still 4. So how it works? The first time the query comes in, right? So we have our proxy between the application server and the data server, and the first time the query comes in, you know, we have this little, you know, select star from table, etc. We send it over to the server for execution. We get the results, and we send it back to the application. Everything's normal so far. This is just normal transparent proxy. We haven't done any magic, you know. There's hardly a reason for us to exist at this point, right? But we also store this result, the actual binary TDS stream containing your result. We store it in memory. And the next time you come, it might be the same application, or it might be another application. It might be a different connection. As long as you meet certain requirements, you know, and you can be served the same result, you will get the same, you will get this cache response. So another server and another copy of the application might send exactly the same query. And what happens is we go like, oh, we already know the answer to that. Bang, here are your rows. And that query never gets executed on SQL Server, on the, you know, subsequent executions. So depending on your workload, there might be some percentage of queries that essentially will be intercepted by SQLProxy, and they will never get to the server, because we're going to serve them serve those queries based on those cached results. So how this query caching works? It's fully transparent to the application. The application doesn't know. It shouldn't, right? That's the whole point of being transparent proxy. The application should never know we're even there. It's fully configurable with cache expiration. It works only for read-only queries, which is obvious, right? It's like, it's not, we cannot cache the, result of an insert, because that insert actually has to happen there. So it's only about read-only queries. It works with parameterized queries and SQLProxy calls. So we also have a solution for if you're doing a SQLProxy call, you can essentially tell us that this SQLProxy is a read-only operation. If you have a parameterized query, so anything that executes it through SP execute SQL, we're gonna cache the results for each parameter combination separately. So as long as the parameter value matches, bang, here's your result. And it uses a time-based expiration. And the reason for that, I'm gonna explain in a second. And it's configurable on the flight with management interface. I haven't shown you how we manage SQLProxy yet, but you probably already have an idea. How would you manage SQLProxy? Something that behaves like SQL Server. Well, you would manage it exactly the same you manage SQL Server, over that TDS connection. So basically we have management commands that you execute from Management Studio, just like you would against a normal server. And it's a special syntax that I'm not sure if we're going to stick with that particular syntax, but it works for now, and it allows us to manage SQLProxy and do all kinds of operations and diagnostics on it from Management Studio, from any client essentially, as long as you have sysadmin privileges. So what about cache invalidation, right? If you cache results of a query, how do you invalidate those results? How are you sure you're not serving outdated, stale data, right? Well, forget about it. forget about cache invalidation, right? Meaning it's too complex and too resource intensive to actually implement it in practice, especially if you have multiple instances of SQLProxy where it becomes a distributed cache. You know, it's like, we haven't even attempted that. We thought, okay, we go for a simple solution because we want performance and we want low overhead. So we're going to go with a simple solution, and we use a time-based expiration. So basically what you do is when you configure a query to be cacheable, you tell SQLProxy how long it should hold the results. Every cacheable query has this time to leave, right? You say, I want those results to be cached, and they're good for 30 seconds. At second 31st, you're going to execute it again, right? Basically, how long you keep this thing in cache is the upper limit of how old your data might be, right? So if you're gonna get outdated, if your application is gonna get outdated data, it's not gonna be older than 30 seconds, right? Because that's the time to leave of the cached result. And after 30 seconds, if the query comes again, we re-execute it on the server and store it in cache again. And that time to live is your decision, right? You configure it. So you look at the query and you decide whether your application can live with a stale data, or if you know that this data hardly ever changes, you can have a time to live, you know, cache expiration in days if you want. But if it's something that changes frequently, it might be, you know, single-digit seconds. Depends. Depends on the workload. So some applications will be fine with the stale data. Some other applications may require more up-to-date information, and depending on what is the query and what we're querying in a database, we would be using one, you know, a smaller value for expiration or a higher value for expiration. Okay, so let me show you a small example of that. So let's say I have, you know, AdventureWorks DW, and I have a little query here that gets executed. Oops. Alright, so this is a query that gets executed and it returns some results. You know, it's just 12 rows. It's nothing really. It's simple, etc. But since it's resource intensive, and how do we know if it's resource intensive? Of course, I can run the query with, you know, statistics.io, statistics time. Let's run it with that, and let's see what it says. And it says, you know, it's only 39 milliseconds. Okay, so it's pretty cool. Let's do. We're going to do client statistics in a second. Okay, so I'm going to show you the client statistics in just a moment. So now, how do we manage SQLProxy? Right? I'm connected through SQLProxy, so I might be querying the SQL server behind it, but I might also manage the SQLProxy itself. So you have this help command that tells you the list of. Actually, let me disable that for a second. So we have a help command that shows you the list of available SQLProxy commands. And we have, for instance, query stats that show you the list of queries that were sent through and how many times they were executed. So kind of the general statistics about your workload and the different types of queries that you have in there. We have a list of queries that are already configured to be cacheable, and I would like to add the query that I just executed to the cacheable list. I would like to make it cacheable. I would like SQLProxy to cache it for me. So the syntax, okay, it's not the previous one, but it's SQLProxy results cache add. Then we have the actual literal text of the query, and then we say expiration 60 seconds. Right? You can also add this query to the cacheable list based on the hash of the query. I'm going to do that in the second example. So I do this, right? And all of a sudden, if I look at this, I have my query right here. This is the query hash, and it's a cryptographic hash, so it's strong, and that means we have no hash collisions to speak of, right? We don't have to worry about hash collisions because hash collisions are improbable for a cryptographic hash. And that's the text of the query, and it says we should cache it for 60 seconds. Okay. Another interesting command that I could use is this, which shows me the actual content of the query cache. I don't have anything in that cache yet. Okay. So now I want to execute my query and see it being cached. Okay, so I'm going to turn on client statistics. So include client statistics, and let's run my query. Bang, right? And it says wait time on server replies 47 milliseconds. Right? Let's execute it again. Right? Got the same result. Wait time on server replies, actually in this case 53 seconds because something probably on the wire went wrong, but bang. Is it really getting cached? So this is, no, it didn't. Might be something wrong with my. So the thing is, just like with SQL Server itself, you need, like with the execution plan caching in SQL Server itself, you need an exact textual match, right? Even a single white space will break this algorithm, right? If it's not the same query, if it's not the same text, and it doesn't hash to the same value, it's not going to get cached. So let's try again, and let's see what happens. I got all kinds of stuff here. Doesn't seem to be caching. Okay, let's. I'm going to approach it from a different angle. I might have a mistake in the syntax or something. This query is cacheable. Some other queries are cacheable. Where is this query that I'm executing? I think this one. Oh, it's actually not. DW. That's the one. There you go. And it says it's not cacheable. That's why it wasn't served from cache. So I have 13 executions, and although 13 of them were cache misses, they went to the server because I misconfigured something. So I'm going to configure it, which is a more reliable solution, really. That's why we have this syntax. I'm going to base that caching on the query hash rather than the query text. So what I'm going to do is I'm going to say, okay, take this and cache that. All right, so now this query, there you go, it's right here, and if I look at the query stats, I can see that this query here, now it says cacheable true. It is cacheable. By the way, what you see here, those results, right? This thing that shows up here in the Management Studio, that's generated by the SQLProxy itself, right? This is not SQL Server stuff. This is our information being sent to you as a tabular result over TDS, which is the proper way of talking between the application and the proxy. And now let's execute that query again, and let's hope that works now. So once, second time, and all of a sudden, you see, my previous execution was 49 milliseconds waiting on the server reply because it was executed on the server. And the last execution, that one I just did, is 1 millisecond waiting on server reply. Because that query never got to the server. It got served by the proxy itself. Notice that the TDS packets received from server, 1 bytes sent from client and bytes received from server. I mean, we got 341 bytes of the original response, and then we got 341 bytes of the cache response. Notice how small those cache responses are. This is how TDS works. The tabular data stream protocol is, pretty compact in how it expresses data. So those 17 rows only take 341 bytes of data. And if I look, I can actually see this result cache. So it says, here's the query text, here's the query hash of the actual, the hash of the text, here's the full cache key that includes some other things like who you are and you know, what's your security context, what's your database context, and a couple other things that need to match in order for this result to be valid for you. And then it says the size of that cache response is 333 bytes, and that's it. That's how much it takes. And this is the creation timestamp. So this is when, this is, by the way, the Pacific time. I have my virtual machine set on the you know, US Pacific time, so it's 8:30 in the morning. And it says expiration 60 seconds. So as long as I keep executing this query, for the next 60 seconds, I'm going to be served from cache. When the 60 seconds elapse, the result is gone from cache, right? It just expired and was removed. So now if I execute the query, it will go back to the server. So now my client statistics say 50 milliseconds again. Okay, let's try it again. And all of a sudden, it's not 50 milliseconds, it's 2 milliseconds. So can this speed up your applications? Yes, it can. Can it offload some of the workload from your servers? Absolutely. Depending on how many queries, what percentage of your workload can be made cacheable. We're talking about, you know, 10, 20, maybe 30% of your queries that will never get to the server and will not reuse resources there and will not have a chance of getting into some form of contention with updates, for instance. So this is an interesting option. Another example. Oh, by the way, we also have a debug mode. You can turn on a debug mode, and that's interesting. When you turn the debug mode on, and you run your query, right? Looks normal, right? There's a little, in the client statistics, we have, sorry, wait, again, in the client statistics, all of a sudden, you know, it was 341 bytes, now it's 655 bytes, the cache response. Because in the debug mode, we appended a little information to your response, right? You got the query results, and at the end of the query results, you got this little piece of information that says, oh, by the way, you know what? If you're interested in that, you were served from cache. And this is the hit for such and such query hash, and the result that you get was timestamped at this point, right? So this is the query that was executed on the server at 8:35:01 a.m. And this is the result that was cached at that time, and this is what you got, right? We also have ways of, you know, overriding cache and things like that. So that's interesting. Yeah, this is pretty much the same demo, so I'm not gonna repeat it. Just a different query, but it's the same idea, right? You execute a query a couple times, and it gets executed only once. And it also works for SQLProxy, but you have to provide us with the list of SQLProxy that we should consider read-only. And it also works for parameterized queries. So if you have an application that parameterizes query, you provide the parameterized text, and that query becomes cacheable. But you will have multiple entries in the result cache for that query, because you will have a separate result cache for each parameter combination. Right? So if it's, you know, parameter is 2, here's your result. If parameter is 5, here's your result, etc., etc. That's how it works. I only have like 5 minutes left, so I'm gonna. I want to wrap up, but I'll be happy to take any questions afterwards or later tonight. What about scaling the SQLProxy itself? You might be asking yourself, right? Like, okay, so I put this little thing between my application and the server. What is going to happen to it, right? What if it goes down, or what if it becomes a bottleneck, right? I know my SQL server is a bottleneck, and now I put the SQLProxy, you know, written by some strange Polish company in front of it. Wouldn't that be a problem? Well, it's not going to become a bottleneck or a single point of failure for you. That's the simple answer, right? Because it's just a gateway, and it's more or less stateless, right? We don't hold any data apart from those cached results, you know, and they are volatile anyway. So we are not a problem because, for instance, if you cannot live with a single instance of SQLProxy because you have too much workload and we cannot handle it in a single process, just create more. Right? How many instances of SQLProxy do you need to, handle your clients? Well, maybe as many as you have clients. So more instances of SQLProxy, spread the load across those multiple instances, and they will all be connecting to the same server in the back end. Right? So multiple gateways going to the same SQL server in the back end. SQLProxy itself supports Windows failover clustering, so you can have SQLProxy clustered as a service. So if it dies here, it will pop up there, etc. We actually have a restart protocol if if something goes wrong, etc. And we consider the state of the proxy to be unhealthy, just recycle the process and start again. And it works with the dash failover partner in the SQL native client because we behave like SQL Server. So in your connection string, you can specify one SQLProxy as a server and another SQLProxy as a failover partner. And SQL native client will be happy to connect to either of them. And as long as one of them is working, you're good. Right? So how do you scale the proxy, right? Okay, that's a little bit too many application servers connecting to this one guy, and we're concerned about this one guy becoming a bottleneck. What if that server dies, etc., etc. Bang. Put the SQLProxy right on the application server. It has another advantage. You're talking to a local service, right? So like you're connecting, your application will be connecting to the database, sort of, right, to the SQLProxy that sits right on the same computer. So it's local. And we hold the results, and your cache is local to you as a client, as an application. Right? And then we connect to the server on the far end if we want to. So we also save on network round trips. By the way, the demo I've done was over the network. Right? So I was connecting from one machine to another, and then I had 2 more virtual machines behind that. But in reality, you could put SQLProxy on the computer where your application works and tell the application to connect to the SQLProxy for its data. So it will be talking to a local service. There will be no network round trips, etc. So that's an actually very interesting solution if your clients are far away from your server and the round trip between the application and the server takes a long time. Or, for instance, if you're using SQL in the cloud. Well, guess what? SQL in the cloud uses exactly the same protocol. It's TDS, right? So you could put SQLProxy as a local cache so that your queries don't have to be sent to the cloud, which really means sending them to a data center in Dublin, right? And Dublin is a good couple hundred milliseconds away. And nothing's going to change that because we're not going to exceed speed of light anytime soon, right? You're working on something, I guess, huh? Okay, good. I want a part of that, right? You can have this local cache that saves you from talking to a far server. And that also means that what happens with, if this server dies, that means that this proxy died together with its client, so we're all good, right? And when it comes up, they will both come up. Right? So that limits any problem with, okay, you have this guy that is a single point of failure, etc. So that's how you can scale SQLProxy itself, just having more instances. So what's in version 1.0? We're actually not on 1.0 quite yet, but getting close to it. In terms of functionality, SQLProxy 1.0 has query results caching that I've just shown you. Query routing between availability group replicas for offloading to your secondary, readable secondaries. And it has an early implementation, I said early because I'm not particularly happy with how it works and I want to improve that, of on-the-fly query transformations. And I haven't shown you that, but it's basically we have a query transformation engine where you can provide your own plugins. You give us a plugin that is interested in a particular query, and we give the query text to that plugin, and what comes out, basically you get the query text and you can do whatever you want with it. and give us back the transformed text, and that's what we're going to execute on the server. So you have this, you can use anything you want. It could be simple, string replace. It could be regex, or it could be actual parsing the query and working with a parse tree to reorder things and do stuff like that. So it can be a simple or very complicated logic that essentially rewrites your queries on the fly. We also have server connection pooling. That's kind of obvious because if you're talking to us and we're talking to the server on your behalf, then the number of connections that we have as a proxy to the server in the background is different from the number of connections that the application calls open, right? Because the application might have 1,000 connections open, but these are going to be connections to the proxy. We're going to have only as many connections to the server itself as we need. So it's going to be essentially the maximum number of concurrent queries that we have run. Because we don't need more than that, right? And based on a quite complicated algorithm, we make sure that your connection from the application matches the connection to the server, so that you're in the appropriate security context, you're in the right database, you're not in transaction, etc., etc. So that's version 1.0. Do we have more ideas for SQLProxy? Oh, by the way, the limitations. Right? Right now we have one serious limitation of SQLProxy. Right? I mean, there's got to be a catch somewhere, right? So right now there's one important limitation. It's SQL authentication only in version 1. We will support Windows authentication soon, but the thing is, it's hard to do, and in order for it to work, you need Active Directory, and you need Kerberos and SPNs. You need all your infrastructure, including SQLProxy itself, perfectly configured so that delegation works, right? If you have no Kerberos and you have no ability for delegation, so we cannot, as a proxy, we cannot connect to the server using your security context, then Windows authentication is not going to work. And that's a limit. Even when we have it implemented, and we're getting there, this is going to be a limitation because in a lot of places it's kind of difficult to configure. It's not going to work with NTLM, no chance. Right? NTLM is just not going to go through a multi-hop authentication. So SQL, and of course SQL authentication is dead easy to do. What more can we do with SQLProxy? We have some ideas for version 2.0 and beyond. Some of those ideas include auditing and logging. It's kind of, I mean, nothing interesting, but the business wants it. There are requirements, legal, etc., etc. So like just, knowing who executed what query, etc. And for instance, what data they saw. Notice that most auditing solutions in SQL Server will allow you to see what queries got executed. But we can actually also capture what results were generated in response to the query. So we know exactly we can know exactly what data you saw. Security, such as, for instance, detecting and preventing SQL injection. Right? Since we look at your queries as they fly through, we can go like, oh, that looks suspicious, right? Why do you have those, apostrophes and dashes, and comment signs in here? They shouldn't be there, etc. So we can essentially capture and prevent SQL injection from happening. We can do error detection and correction. One of the first things that we're going to do in version 2.0 is automatic retry of your transaction after a deadlock. If you become a deadlock victim, we will retry it for you. You're not going to even know. Why? Because so many applications out there do not have proper, detection and handling of deadlock victim of 12.05 implemented. So they just crash or show an error message to the user where it could be easily fixed by just retrying the transaction. So we're going to do that automatically. Translation between SQL dialects. So you have something that is no longer supported, for instance, and you have compatibility problems because you have an application that is using a statement or syntax that is no longer supported, etc. We can fix that for you on the fly. So compatibility with new versions. Data obfuscation, I guess we're not going to do that since it seems to be implemented in SQL 2016, so there's not going to be need for that because now it's built in the product. And T-SQL language extensions. You know, with this, we could actually think about extending the language itself. As in, you send us something that is not really T-SQL, and we transform it into something that SQL Server understands. You know, I have some ideas there, but I'm not going to talk about them right now, especially that I have already exceeded my time. So, what's next? Well, first of all, we're in the private beta stage. So basically, we're not giving the bits away yet. I talk to clients personally, and I kind of oversee any tests, etc., because we want feedback. We want to understand how it works and what it does. You know, how it behaves with different types of workload. If you're interested in SQLProxy, I want to talk to you. If you want to try it with your application, with your workload, I want to talk to you even more. So essentially, come and grab me during the party, and I will answer all your questions. I'll tell you whatever you want about SQLProxy, and we can talk and you know, exchange some ideas of how it could work for your particular application. And of course, we can have a drink together while we talk about SQLProxy, which is an added benefit. You can visit us at www.sqlproxy.net for updates and more info later. I mean, that website is you know, it's hardly existing. I mean, it's only landing page right now, but we will be publishing more information and probably some more public version of the software over there. So just check that website for updates. And with that, I would like to thank you very much, and I hope you enjoyed the first day of the conference, the main conference today. We're going to have a discussion panel here pretty soon with all the speakers, Q&A session, and then of course followed in about an hour by a party over there. And we all look forward to that party, right? And free beer and food and beautiful girls, and you know. So enjoy the rest of the evening. Thank you very much.